Hi, welcome to another tutorial of Apache Spark. So in this tutorial, we will try to understand what are the limitations of Hadoop, what is the difference between Hadoop and Spark, what are the limitations of Hadoop MapReduce model. We'll understand the need of Spark. We'll go to the introduction of Apache Spark. We'll understand the Spark features, and then we'll go to Spark ecosystem and we'll try to learn the different components of Spark ecosystem. We'll also understand what are the use cases of Spark and how Spark works. So there would be an approach wherein we'll understand what is the core of Spark and what are the components of Spark, and we'll go one by one into that definition. So let's get started with Apache Spark. So you guys know that big data is again a big deal nowadays, and why we need another model when we have Apache Spark, when we have Apache Hadoop with us. So what happens, like industries are nowadays acquiring Hadoop like anything, and they are using it for analyzing the large data sets, the petabytes of data. And this is because of the reason that Hadoop framework is actually very simple, and the MapReduce model is very much simple, and it is scalable, flexible, and fault tolerant as well. Now, the one more thing which is very much positive with Hadoop is that it is cost effective also. So in case if you want to scale Hadoop, it will be very cost effective also. So what happens, like when you scale it, when you scale Hadoop, there is some latency which actually gets added to the system, and at times when you are doing some iterative models, when you are applying some machine learning techniques, and when you need to do the repetitive iterations, the Hadoop, it tends to become bit slower. So here the requirement of here is the requirement of a model of technology which is faster, which gives you the faster results and the low latency model when it comes to the iterative modeling and all. And hence the Spark was introduced in Apache Software Foundation in 2013. So people have that a common belief, I mean, and that's an interview question also, that is Apache Spark a modified version of Hadoop? So the answer is no, because Apache Spark is not at all the modified version of Hadoop. However, it uses the Hadoop functionalities, MapReduce model, in order to perform its operations. So why it is not why it is using Hadoop? Because Hadoop has got the effective modeling of MapReduce, and Spark takes that advantage of speeding up the system, speeding up the analysis, speeding up the processing of data on that MapReduce model. Now Apache Spark has got its own cluster management, and this cluster management is its own, and it does not depend upon MapReduce and Hadoop. However, in one of the model you can also use Hadoop, but it's not completely dependent on Hadoop. So Spark has got its own usage and usage of storage and the processing. However, Spark can also use Hadoop storage part in one of the models. So we'll see that those models where exactly the Apache Spark is actually using the Hadoop storage model. And let's move ahead and see what exactly the problem MapReduce we were facing, and how Apache Spark is beneficial in order to remove that, or resolve those problems. So guys, earlier we had MapReduce, and now what are the MapReduce problems? That in MapReduce model you cannot define certain problems. That means that the MapReduce model is not fit for some of the essential analytical techniques where you can actually apply all those models and you can get the desired results. Also, the persistence of disk typically slower than in-memory work. So that means that once we have the data, we have to store it in our regular storage, and when you actually try to fetch the data from that storage, it actually tend to become slower. So the solution for this problem was given by Apache Spark, which is a general purpose processing engine that can be used instead of MapReduce. Now, what Apache Spark offers us is in-memory computing. What exactly in-memory computing is? That means you need not to store the data in your regular storage. You can store that data into the RAM, and as we all know that RAM is always faster than fetching data from RAM is always faster than fetching the data from the regular storage. So in that case, Apache Spark give us an advantage of in-memory computing, from where we can fetch the data and process the result faster. We'll see that in a while also. So that's a basic difference between Hadoop, Apache Hadoop, and Apache Spark. And what exactly Apache Spark offers us is that in-memory cluster computing, and again it increases the processing speed of the application, which was a bit slower in Hadoop as compared to Spark. However, Hadoop is also faster than many of the traditional applications, but Apache Spark is faster than and in Spark, and to be very honest, Apache Spark is one of the fastest model we have right now for analytical purpose. So let's go ahead. So what exactly Apache Spark is? So if we go about the definition says that Apache Spark is uh, lightning fast computer technology designed for fast computation. It is a powerful open source project engine built around speed, ease of use, and sophisticated analytics. So it was developed nearly in 2009, where it was where people were trying to find out the alternatives of Hadoop, and they were trying to find out what exactly could be the best analytical solution. So in that case, it started in 2009 within AMP Labs, and this lab is like this organization is situated in University of California, Berkeley, and where it actually took some shape, and then it was donated to Apache Spark, and now Apache Spark is one of the Spark is one of the biggest and project in and biggest and important project in Apache Labs right now. So it was optimized. uh, Apache Spark is basically optimized to run in memory, helping processing data far more quickly than alternative approaches like Hadoop, MapReduce. Uh, Now what is it does is it tends to write the data to and from computer hard drives between each stage of processing. Its components claim that Spark running in memory can be around 100 times faster than Hadoop MapReduce, and also it is around 9 to 10 times faster than it when it comes to processing. So as you can see, the speed of Apache is way beyond way faster than the Hadoop MapReduce model. Now you will not be able to realize it when you have the small data sets, but when it comes to the petabytes of data, when you need to analyze the terabytes of data, and you are doing some unstructured data analysis, you will get to realize that it is up to 100 times faster. It can scale up to 100 times faster, and also it is utilizing less number of resources as compared to Hadoop MapReduce model. So how Apache Spark evolved? Apache Spark has been got the very much attention from enterprises, and there a lot of companies are using Apache Spark right now, and which is actually very helpful to them. Uh, so there are a couple of big shots in the enterprise customer like Netflix, Yahoo, and eBay are they are actually deploying Spark to get to get the very fast computing and analytical powers, which will They have deployed Spark at massive scale, collectively processing multiple petabytes of data on the cluster of over 8,000 nodes. So again, the highest number of nodes that can be added in Hadoop model was around 4,000, and beyond that, the Hadoop model, started, giving you latency and some lot of errors and node failures. Whereas in Spark, it has been extended up to 8,000 computers and 8,000 nodes, and it ran successfully and proven to be a faster solution. Now, because of these speed and the functionality, it has become the largest open source community in big data. So that means that the people are contributing a lot in Apache Spark, and it is one of the fastest growing technology and a project in Apache right now, where people are exploiting and leveraging the speed of Apache Spark. We have around 1,000 contributors and more than 250 organizations which are working on this platform and giving it, giving their inputs and trying to improve as much as they can. So why again, as I've given you the introduction of Apache Spark, and we'll understand how it is faster than any other technology or the Hadoop MapReduce itself. We'll see why Apache Spark is in the picture, and why people prefer to use Apache Spark than Hadoop, where it comes to speed and latency problem. So as I've given you the one of the clue, that speed is around 100 times faster in memory and 10 times faster on the disk. It is very easy to use. It's very easy to use Spark. Now what happens, guys, people from because analytics domain is in the boom right now, and people are from different backgrounds and coming in this analytical domain. They might know Java, they might know Scala, they might know Python or R or some other programming language. So Spark is very much easy to use when it comes to apply the model or use Spark. It's very easy. Yeah, a person who knows Java, Scala, Python or R, or maybe from any other programming background, they can use Spark very easily, because it is very easy to to work on Scala and Spark. And also it is very sophisticated to use Spark, because it runs on it is built around Scala, and it has some concept of RDD, which we'll see in upcoming slides. And it also supports SQL queries, streaming data, and complex analytics. This is actually the one of the main point, sophisticated analytics. Why? Because people who were using streaming data and complex analytics, they had to analyze the data over and over again. And once you analyze the data over and over again, and if you are aware of machine learning technologies, then you have to apply some model on this data, and then you get some results, and then you check whether the results are feasible or not. Again, if you find that the results are not feasible, and then you may want to go ahead with a different sort of machine learning algorithm, then you apply again those results, those algorithms in the data, and then it goes then the results comes out, and you compare the results, which results gives you the better prediction, what exactly the confidence interval of the result is. So it is essential for a data scientist to do the iterative sort of testing when they are working with data. So, and when it comes to large data set, it is very much impossible to spend time again and again on the large data set. Suppose you have several petabytes of data, and you want to apply some machine learning techniques to it, and then you analyze the results. And if you want to analyze the that data again, you have to put in the same efforts again, and it takes time, and it adds latency to the project. So here, if Apache Spark comes for the rescue, it gives you in a model wherein you apply the techniques, and every time you run the algorithm on it, becomes faster and faster. We'll see how it becomes faster every time. So let's move ahead. Now we understood why Apache Spark is needed, and what exactly the features of Apache Spark is. Let's understand some of the some basic features of Apache Spark. What exactly Apache Spark has for us, and what it actually offers. So Spark is an all-purpose data processing engine that can be used in variety of circumstances. Now here this small line has got a lot of meaning built in it. What these features are like, in what happens like in MapReduce, if you know Java, then only you can code the MapReduce sort of task. And once if you want to use Hive, you have to install another another package on it, and then you learn what exactly the MapReduce task is, and then you program your SQL sort of queries with Hive or Pig, or you want to apply some machine learning techniques, so then you need to learn all those stuff. Here what it does is actually gives you built-in all those qualities. If you want to use machine learning techniques, they are all built in. Once you need to install once you have installed Spark, it is all fine. I mean, you need to start working on it. You can start working on it immediately, and it won't give you any problem. So in Hadoop, you have different plug and play techniques, wherein once you have installed Hadoop, you have to use those plug and play techniques in order to make the things going on. However, in Spark, everything is built in. You can use the machine learning libraries, and you can use graphics technologies, which is one of the fastest one of the biggest and largest using technologies nowadays, used for recommendation engines and all. So these are all built-in things which you can use in order to perform certain tasks here. Application developers and data scientists can incorporate Spark into their applications to quickly query, analyze, and transforming data at scale. That's a self-explanatory statement which says that the people who knows people who know different type of language, and data scientists who know everything about the programming of the Scala and Python and R on different SQL, then they can actually use those data set and Spark technology to in order to process the data, query the data, analyze the data, and summarize the data in a very fast process, in a very fast manner. So again, Spark is actually optimized to run in memory, allowing it to process data for more quickly than alternative approaches like Hadoop MapReduce, which tends to write data to and fro from computer and hard drives between the stage of processing. So guys, what happens, like we know the concept of RAM. So if we use a lot of if we use some files on regular basis, and and we use it more frequently than any other files, so what happens that the system puts those files into the random access memory, and once it is being fed into the random access memory, as soon as you click on it, computer can fetch it faster. So any of the server, if the program or the data is in memory, it can fetch that particular data faster than any other then it is fetching it from the regular storage. So what happens, the Spark utilizes this feature, and it actually stores the data in RAM rather than going for the regular storage. It stores the data into the RAM, and once it fetches the data from RAM, it is faster than the MapReduce model, because what MapReduce does is then it fetches the data and analyze the data, and then after doing the map and reduce job, it stores the data back to the HDFS system. In order to, if you want to fetch the data back again, you have to go to the storage and then you fetch the data again, rather than storing that data into this into the regular storage. It actually stores the data into memory, and once it is stored in memory, it is very much easy and faster than the previous jobs, that you can fetch the data from memory and perform some analysis on it between the age of processing.